Hi guys, so today we're going to go a little further into geometric sequences, and just a reminder, the nth term of a geometric sequence is here. So we have seen this type of problem before in this example where we're given certain terms of sequence, and we did that with an arithmetic sequence, so it could happen with a geometric sequence as well. Just to keep everything consistent, I'm going to start it off the same way I did with the arithmetic sequence, where I'm going to note the term number, which is first term, second term, third term, fourth term, and fifth term. And a sub n would be the actual value of the term, which in this case, the second term is 5, and the fifth term is negative 78,125. So remember that to get from one term to the next, since this is a geometric sequence, I would multiply by the common ratio r. And then I would continue this just to kind of see how would I go from the second term to the fifth term? What's that relationship? Well, if you remember, we added for an arithmetic, so for geometric, we're multiplying r. So 5 times r times r times r would give me the fifth term, which is negative 78,125. So r times r times r, remember when you're multiplying like bases, you add their exponents. So this would give you 5r to the third power equals negative 78,125. I'm going to solve for the common ratio for this sequence by dividing both sides by 5. And r to the third power would give you negative 15,625. Now, I need to get r by itself. It has a power of 3. So just like to get rid of a square, you use a square root. To get rid of a cube, you use a cube root. A cube root is nothing more than a power of 1 over 3. Just like a square root is a power of 1 over 2, fourth root is a power of 1 over 4, so on and so forth. And I'm only noting that because a lot of calculators don't have a cube root button. So the equivalent of it is just to type into your calculator negative 15,625 to the, and in parentheses, 1 divided by 3. So to the power of 1 over 3, make sure that that exponent is in parentheses, and your ratio should be negative 25 when you're done. By the way, the cube and the cube root get rid of each other because when you have a power to a power, you multiply them, and 3 times 1/3 is just 1. So we have our ratio. I'm going to note that up here. We have r, which is negative 25. I'm going to bring down the n minus 1, the a sub n equals, and all I need now is the first term. So just like you would multiply by the common ratio to get from one term to the next moving forward, you would do the opposite to go from one term to the next to find the first term. So remember, the ratio is just whatever term divided by its previous term. So I'm going to write this out just to find the ratio. Now I know that the ratio is negative 25. I know that my second term is 5, and I'm looking for the first term. So little algebra, please do not divide the 5. You could, but a sub 1 will not magically move up. So you still have a fraction. This would be 1 over a sub 1. So just to get rid of the fraction first, I'm just going to multiply both sides by a sub 1. I'm going to get rid of the denominator so that I no longer have to deal with the fraction. So I have negative 25 a sub 1 equals 5. And then just to get a sub 1 by itself, divide both sides by negative 25. And when I reduce this fraction, a sub 1 will equal negative 1 over 5. So my first term is negative 1 over 5, and there is my equation. I'm not going to multiply these two because remember, PEMDAS, exponents come before multiplication. So since you don't know what n minus 1 is, and the base of that is negative 25, you can't actually do anything until the exponential part is solved to multiply. All right, guys, that's everything for now. I hope this helps.